Hello, friends. We're continuing our lessons in AP Precalculus, or Precalculus in general, if you want. Today we're going to be introducing another way of measuring angles. You're familiar with degrees, right? 360 degrees describes a circle. But today we're going to be defining things in terms of radians, understanding what a radian is. And then we use radians a lot for the rest of this unit. Even in physics, we use radians on a regular basis. So it has its uses as well. And so, again, review standard position is the positive x-axis, the terminal ray, right? So we imagine these lines, these rays forming angles, and positive is measured counterclockwise, right? Negative angles are measured clockwise. Keep that in mind. And so, one way of measuring an angle is in terms of how far around the circle it goes, okay? And one way of measuring how far around the circle you are is how many radii could you stretch out along the circumference? Well, if we ask ourselves that question, well, in a full circle, how many radii can we stretch out around the circumference? The answer would be 2 pi, right? Because we know that the circumference is calculated as 2 pi r. So there are, what's that? 3.14 times 2, so 6.28, etc. radii that you could stretch around the circle. So in other words, you took the radius, that length of the radius, and you stretched it out. You could line up about 6.28 of those radii as you went around. Okay, and so if we had something like this, a circle, we had this angle, that the angle, you take the terminal ray, that if you stretch it out and you go, from the origin all the way around to where the angle is, you're describing an arc. And that arc you can describe in terms of how much of a circle are you taking up and how many radians are there. So a radian is a stretched out radius along the circumference of a circle. And then the angle that's described by that radius, or how many radians you've got around the edge of the circle. Okay, so that's what a radian is. So let's think about this for a second. It says consider the angle theta created by the quarter circle. It says find the measure of theta in radians. Okay, well, we would take this as the arc length of a quarter. That's not a quarter of a circle. All right. Well, that's going to be the arc length of a whole circle. Whole circle divided by 4. Well, what would that be? That would be 2 pi r divided by 4. And this ends up being pi over 2 r, right? Or pi over 2 radians. That's what we have there, right? 2 pi r, again, this would really be the circumference. It's not quite the angle measurement. But we're saying is 2 pi radians. And so what's happening is I'm kind of taking this and turning it into a unit here. And so the angle measure of a quarter of a circle from here to here is pi over 2. Okay. Pi over 2. I find it's helpful to kind of be able to translate back and forth between degrees and radians. And so this is 90 degrees. That's what you're familiar with. Okay, so it's just another way of measuring angles. Just like we have inches and we have centimeters, different units. And so we have different units for angles as well. It says find the measure of the angle formed by a third of a circle with radius 3 centered at the origin in the clockwise direction. Okay, well, the measure of the angle, right, or the radius isn't going to make any difference for the measure of the angle. Right? So let's draw this out. Okay, and so going a third of the way around, so here's one ray. Here's the terminal ray is going to be somewhere over here. So I'm only going 1/3 of the way around the circle. So it's only 1/3 of 2 pi. Right? And this is negative, by the way, because I'm going clockwise. And so this ends up being negative 2 pi over 3. Okay, so that's it. It's 1/3 of the full circle. The full circle is 2 pi. What would this angle be in degrees? This would be, if we're going 1/3 of the way around, 360 divided by 3 is 120. And so this is negative 120 degrees, if you want to think about it that way. Notice that gets us to the same place as if we had 240 degrees. Right? If we went positive 240 degrees, that would get us into the same position. Right? So we have to pay attention to the direction and that sort of thing. Okay, now since the radius doesn't matter, most of the time what we do is we talk about all of this in terms of the unit circle. Okay, unit means 1. That's what that word means. Unit, think like university, univocal, lots of words that begin with uni, which means 1, right? And so a unit circle, the unit means it has a radius of 1 all the way around. Okay, and so we're going to be using that quite a bit. So it says, for each of the following, sketch a picture of the arc length described based on a unit circle, then find the measure of the angle corresponding to the given arc length. Okay, so I'm going to make a unit circle. So 1/6 of the circle in the counterclockwise direction, that would take us to about here, maybe. And so 1/6 of 2 pi. I'm going to cancel out there. So this will be pi over 3. Okay, that's that angle measurement. And 1/6 of 2 pi will be 1/3 of 180. So that would be about 60 degrees. And so maybe I drew that wrongly. Uh-oh, that was too much. So this is probably more like this, because it's 1/6. Right. I was thinking 1/6 of half the circle. It's 1/6 of the whole circle. All right, 2 full revolutions in the clockwise direction. Whoa, 2 full revolutions. Well, that's 1 revolution is negative 2 pi, and then another full revolution would be another negative 2 pi. So it's negative 4 pi. That would be negative 720 degrees. 3/4 of a circle, 3/4 of a circle in the counterclockwise direction. Well, counterclockwise would be this way, and 3/4 of the way around would be here. So that would be 270 degrees in terms of degrees, but 3/4 of 2 pi would be, the 2 cancels out, so this is 3 over 2 pi, or 3/2 of pi. 7/8 of a circle in the counterclockwise direction. So 7/8 times 2 pi. This is going to be 7/4 of pi. 7/8 is going to take me most of the way around to about right here. It's auto-correcting for me. Thank you, I appreciate that notability, but it's not what I want. So it's here. Okay, positive 7/4 pi. Now this would be something like 315 degrees if it was in degrees. And so what we can do is we can fill this in. This is the unit circle. I would recommend, highly recommend, memorizing the unit circle. There's a pattern here, okay? And so once you pick up on the pattern, you don't have to memorize each individual thing, and it's like, filling out a geography map. Find the pattern, remember the pattern, and then you have to just remember a few things, and you can repeat the pattern as you go around. All right, halfway around the circle would be pi here, right? And like we've been figuring out. So then we get to pi over 2, and then notice that we have another 6th here. So this is 2 pi over 3. This would be 3 pi over 4. This would be 5 pi over 6. Okay, and then 1 pi would be what we call 180 degrees normally. And then going all the way around, we have 7 pi over 6, 5 pi over 4. This is 9 pi over 6. Sorry, 4 pi over 3. Let's do it that way. 4 pi over 3. Again, all the positive angle measures going counterclockwise from the positive x-axis. This is 3 pi over 2. End up with 5 pi over 3, 7 pi over 4, and 11 pi over 6. Okay, and so really what's happening is here, these are chunks of 1/6, right? Or really 1/12, I should say. There are 12 of these evenly spaced throughout. And each of them then is 30 degrees. So this is 30, this is 30, 30, etc. And so we notice that we have in the denominator, right? So this is 1/12. Or you could think of it as a sixth of pi, right? 1/6 of going halfway around. So we get pi over 6. And then this is pi over 3 would be 2 pi over 6. So that simplifies. And this would be 3 pi over 6. This one would be 3 pi over 6. And so that becomes pi over 2, etc. So these are, your whatever it is over 6. Then, let me erase that stuff. Erase all of this. You have these others that are dividing by 4, right? And so you're dividing the whole thing into quarters, really eighths, actually, right? Quarters would be, again, I typically think in terms of what pi is, so dividing pi by a certain amount. So if we take halfway around, like to here, if we divide that by 4, so what's this going to be? This is 45 degrees. All right, and so let's fill this out with our degrees. This is 30 degrees. This is 45 degrees. This is 60 degrees. 90 degrees. And then, maybe I should have done this in a different color. 90, and then again, intervals of 30 here. So this is 120 degrees. 100 and, what is this, 35 degrees, 150, 150 degrees, 180 degrees. Again, you're familiar with that. So 210 degrees, 225 degrees, this is 240 degrees. Again, follow the patterns. 270 degrees, this is 300 degrees, 315 degrees, 330 degrees, and then this is also, besides being 0 degrees, it's also 360 degrees. It's 0, it's also 2 pi radians. So again, radians and degrees, different ways of measuring angles, and memorize this, because there's more that we're going to add to this that you're going to memorize later on. And being able to kind of access this and organize it in your head is going to be an important skill. And I would say that the unit circle is a thing of beauty because of the structure, the order that's here, the patterns that occur, and yet the unity of it, just based on a few basic principles about the way that we measure angles and the way that we calculate trigonometric functions. There's a high degree of order and unity here, and that's what beauty is. So let's carry on. Sine, cosine, and tangent in the unit circle. So like I said, we get into the trigonometry with this. For the unit circle, again, the radius is 1. The way this works then, since the radius is 1, that means that the hypotenuse has a length of 1. Right? And like we saw before, sine is the y-coordinate over the hypotenuse. That means then that since the hypotenuse is 1, sine is just going to be the y-coordinate, whatever the y-coordinate is. And cosine is going to be the x-coordinate, because it would be x over the hypotenuse, but the hypotenuse is 1. And then tangent is y over x, or sine over cosine. So let's look at some examples here. All right, we have a point here where the x-coordinate is 1/2, and then we have 3 pi over 2. This is actually pi over 3, or 60 degrees. Again, you'll memorize these later, but I'll just give that to you now. So the figure shows a circle centered on the origin, where theta is in the center position. Here are the coordinates, find the values. So sine of theta is the y-coordinate. It's just root 3 over 2. Cosine is the x-coordinate. That's 1/2. And then tangent is sine over cosine. Right? Or it's the y over the x. And when we simplify this, we just end up with root 3. It's okay, tangent is the one that can be bigger than 1. Example 6. The point R is the result after point is reflected over the y-axis. Let A be alpha, that's actually alpha, not A. Let alpha be the angle in a standard position whose terminal ray intersects the circle above at point R. Okay, so R, so we reflect this over, or reflecting it over the y-axis. Okay, when we do that, it'll end up over here. Based on the information, we know that R has coordinates negative 1/2, but the same y-coordinates, root 3 over 2. So sine of alpha, root 3 over 2. Oh, alpha, I should draw it in here. Alpha looks like that. Root 3 over 2. Cosine of alpha is negative 1/2. And then tangent is going to be the same as it was before, root 3 over 2 divided by negative 1/2, except that it's negative. Negative root 3. So just some basic practice using coordinates, and then with the definition of radians and an introduction to the unit circle. Again, start memorizing the unit circle. It's going to pay big dividends in the future. And I would say you get to see one of the things that is beautiful about mathematics, even at this kind of basic level. So thanks for watching. Don't forget to like and subscribe.